Hello, in this video we'll be talking about topic 2.1 of the AP Chemistry curriculum, types of chemical bonds. So the type of bond that will form between two elements when they react with one another depends on the electronegativity of those elements. And electronegativity has to do with properties of the atoms that we've talked about in a previous video, periodic trends, where the energy level, the effective charge, and shielding are what determines how strongly an atom will pull an extra electron to itself. So we're just going to talk about the trends in this particular video. And if you notice on this chart here, as you go across any of these periods, the electronegativity tends to increase from the metals with low electronegativities generally to the nonmetals with higher electronegativities generally. And remember, the metals and the nonmetals are separated by the stair-step line that is right here. So when two atoms interact with one another, if they have high electronegativities, each of those elements does not want to give up an electron. They both want to attract electrons to themselves. And so if both atoms have high electronegativities and a high attraction for extra electrons, that means that they're not going to give up any electrons. So instead, the two atoms will share electrons. So when two nonmetals interact with one another, they will end up sharing electrons, and sharing valence electrons, is called a covalent bond. And in covalent bonding, the electrons are shared in the outer shell in order for each atom to achieve an octet, to have 8 valence electrons in their outer shell, typically. If there is a very small difference between the electronegativities, then we say that you have a nonpolar covalent bond. So if you look, for example, at phosphorus and hydrogen, phosphorus and hydrogen both have an electronegativity of 2.1. And so because of that, one atom is not going to pull the electrons any more than the other atom. And so if you have a nonpolar covalent bond, then you have equal sharing of electrons. Both atoms pulling equally. Even if there's a slight difference, for instance, if you had carbon and hydrogen, that's a very small difference in electronegativity, and so you're not going to have much of a difference in pull on electrons between those two elements, and so you have a nonpolar covalent bond. If, however, there's a larger difference in the electronegativities, then you're going to end up with what's called a polar covalent bond. And in a polar covalent bond, you have unequal sharing of electrons. So you still have sharing going on, but one of the atoms is pulling on the electrons with more force than the other one. And so it's an unequal sharing of the electrons. So nonpolar equal sharing, polar unequal sharing. So for instance, let's think of a water molecule. In a water molecule, you have a bond between hydrogen and oxygen and another hydrogen. So if we look at this bond between hydrogen and oxygen, hydrogen is sharing electrons with oxygen. Oxygen's electronegativity is 3.5, and hydrogen's electronegativity is 2.1. That is a fairly substantial difference in electronegativity. And so that means that oxygen pulls the electrons more towards itself, with hydrogen not pulling as hard. And so it creates what we call a dipole, and a dipole is simply a representation of the unequal sharing of electrons. And we can represent the dipole by drawing this arrow towards the more negative side of the bond, and with a little plus sign on the more positive side. Another way that we can do this is show what's called partial charges. The hydrogen has a partial positive charge because the electrons are being pulled off more strongly than by the oxygen atom. The hydrogen has slight less electron density than it would by itself. So we call this a partial negative. This is the Greek letter delta with a little positive sign. I think I said negative, but positive. So delta positive. That means this is partially positive. If there's a partial positive, then there must also be a partial negative, and that's the oxygen. The oxygen's pulling electrons towards itself, and so there is a slight higher electron density around oxygen than it would have by itself, and so we give it a partial negative. So you can draw a dipole arrow to represent this unequal sharing of electrons, or you can use these partial charges to show the unequal sharing of electrons. And the same is going to be true on this other side. This hydrogen is also having electrons pulled unequally from it. And so we actually have two dipoles created within the water molecule. So that's polar bonding, and again, it has to do with larger difference in electronegativity. If you have a very large difference in electronegativity, like between a metal and a nonmetal, then the nonmetal pulls the electron right off of the metal. And when that happens, you end up with a transfer of an electron. And when you have a transfer of electrons, that equals ionic bonding. And on ionic bonding, you have the electron move from the metal atom to the nonmetal atom, and you create ions. The nonmetal atom becomes a negative ion, an anion, and the metal becomes a positive ion, a cation. And in ionic bonding, there's a large electronegativity difference between the two atoms. Now, if you'll notice, I'm kind of using vague terms: large difference, medium difference, small difference, and that's because this idea of covalent and ionic bonding is actually a continuum. There's not a clear division between ionic, which is a transfer of electrons, and covalent, which is sharing of electrons. It's kind of a continuum between the two. And so the best way to tell whether you have ionic bonding compounds or a covalent bond is by just looking at the physical properties of the substance and seeing how they behave. Ionic compounds, when they dissolve in water, are electrolytes. Ionic compounds typically are brittle and have high melting points, whereas covalent compounds with covalent bonds, typically have lower melting points. They don't have electrolytic behavior in water, etc. So that's one of the best ways to determine if you have ionic bonds or covalent bonds. The other type of bond that we haven't talked about yet is metallic bonding. And in metallic bonding, you have metals interacting with themselves. And metallic bonding, you have what's called a sea of electrons. And a sea of electrons simply means that the valence electrons in each of the metal atoms are being shared with all of the other metal atoms. So you end up with what's called delocalized electrons. So if you had a whole bunch of atoms of metal, their valence electrons would actually be shared and moving constantly, jumping between the atoms of the metal. And so because these electrons can move around, we say that they're delocalized because they aren't actually on any particular atom. They're not local to one atom. They're delocalized in that they can move to any other atom. And so that's metallic bonding. So covalent bonding is sharing electrons, ionic bonding is a transfer of electrons, and metallic bonding is a sea of electrons shared between all the different atoms. If you have any questions about these definitions of bonding or what a dipole is, please let me know, and I'd be happy to help you with a little bit more information if you need it.